going to learn about the JVP waveform, which is basically the measure of the jugular vein. So, jugular venous pressure. So, basically, JVP is jugular venous pressure and it is connected to the superior vena cava, which is connected to the right atrium. So, you can say that JVP is indirectly the presentation of the pressure in the right atrium. As the pressure in the right atrium changes, it increases or it decreases. It reflects the changes in the superior vena cava pressure and in turn it reflects the changes in the JVP, which can be easily measured. So, on the basis of the changes in the pressure of the right atria, we have the JVP waveform, which directly or indirectly shows the changes. So, we have three positive changes A, C and V and two negative changes X and Y. Positive changes mean to say there is an increase in the pressure of atria, basically the right atrium, because SVC is directly connected to the right atrium. And there are two negative changes, or you can say there is the decrease in the pressure of the right atrium, which is shown by the waves X and Y. So in the JVP waveform we have 3 increase and 2 decrease. Okay, now we will learn step by step that what happens in our heart to show the JVP. Okay, so when we will talk about the A wave, as you can say it's the plus or rising wave. So what might be the reason for this? So basically it is the wave which measures the pressure of right atrium during the time of the systole. So basically atria contracts and it formulates the flow of the blood to the ventricle via the tricuspid valve. So this is where the systole of atria is occurring. Okay, so right at the point of the atrial systole we have the A wave, which is basically the slight increase in the pressure of the atria. Okay, now we'll talk about that. After the systole of the atria, the blood will try to go into the right ventricle via the tricuspid valve. So during this time, after the blood goes into, there is a time of isometric volume contraction, and after the blood goes into the ventricle, the blood in the ventricle, although the valves are closed, but there is a slight bulge in the valves due to the pressure of the blood which has been sent into the ventricle via the atria. Mark my point, although the valves are closed, but there will be a slight bulge due to the pressure of the blood which is being sent via tricuspid valve from right atria into the right ventricle. So this causes a slight increase in the pressure of atria due to the bulging of the valve. So here bulging is happening and this causes a slight increase in the pressure. That's why there is a slight curve which is C, denoting the positive pressure in the atria. After that, there will be the opening of the aortic and pulmonary valves, which formulates the ejection click, and the blood from the right ventricles goes out through the pulmonary artery, and left ventricle goes out through the aorta. Okay, so here we will talk about the right side of the heart. So here you will listen to the ejection click sound, and this is the time when our ventricle is in the contraction state, or there is ventricular systole happening. So at that time, when all the blood of the ventricles is released or sent out, the bulging will be returned into the normal position, and there will be the slight decrease in the pressure of the right atrium. So basically you can see there is a slope going downwards, which is denoting the negative pressure in the right atrium. After that, all the blood goes out from the ventricles. There will be the passive filling, or you can say venous filling of the right atrium, which is happening through the superior vena cava. So blood will go directly into the right atrium, which is basically the venous filling, and it will also contribute to the increase in the pressure. So while all this happening, right after the blood goes out of the right ventricle, there will be passive venous filling in the right atria. So basically this is going to again increase the pressure in the right atrium, and this is shown by the V wave, which is again the positive deflection, positive wave rise. So this is basically the isovolumetric relaxation. When the venous filling is happening in the right atrium, all the chamber of the heart is in the relaxed state or in the diastole stage. Now comes the Y wave, which is basically again the negative. So what happens here is all the blood which is coming into the atria through venous fillings goes into the ventricle. So it is causing the rapid ventricular filling. So rapid ventricular filling causes sudden decrease in the pressure of right atria, which is shown by the fall as a Y wave. So again here we justify that there are three positive waves, including which denotes the increase in the pressure of right atrium, with two decrease which denotes the decrease in the pressure of the right atrium. So this is how the mechanism of the heart works, and it instantly changes the jugular venous pressure, which is pulsatile and sometimes non-pulsatile as well. But we have different pathologies associated with the pulsation in the JVP. That is a different thing, but for now we are very clear about the JVP. So I hope you guys understand the video, understand this lecture, understand the waveform of JVP. So if you like the video, do hit the like button, subscribe to my channel and share as much as possible. Thank you for watching.